Section 4.5c. Now we look at some exponential equations. So basically what we do, because exponential equations here will be a little bit complex than the ones we did earlier. So what we do in some of these, that we break them down into smaller and simpler exponential equations and then solve those. And sometimes substitution will work. So there are different situations. So let us look at the first example here. So it says solve the exponential equation, which is given as e to the 2x minus e to the x minus 6 is equal to 0. Now remember something like this, a to the m times n is the same thing as a to the m whole raised to the n, or a to the n whole raised to the power m. So we can write it in any way. So the term e to the 2x, if you think, it is actually e to the x whole square. Okay? So what we do in these problems, when we see e to the 2x and then e to the x, when you see these two terms, and it doesn't have to be e, it can be any number. So a to the 2x and a to the x. If you see these two in the equation, then we call them the quadratic form. This equation is of quadratic form. So we can do substitution. We say let u is equal to e to the x. Then u square will be equal to e to the x whole square, which will be what we have here, e to the 2x. So now when you look at the given equation, you can see, it can be simplified as u square, because u square is e to the 2x minus u minus 6 is equal to 0, which means we can factor it as u minus 3 times u plus 2, which gives me u is equal to 3 or u is equal to 2. But remember what u was? U was e to the x. So you say e to the x equal to 3, or this is negative 2, by the way. So e to the x is 3 or e to the x is negative 2. Now if you recall, e to the x is never negative. So if you recall, you can cross it over here and you just solve this one, e to the x equal to 3. So how do I solve this? Well, what form is it in? Exponential. So we can convert to logarithmic form. Okay, so what will that be? So we apply ln on both sides. So ln of e to the x will give me e to the x. Will give me just x. And x is equal to ln of 3. What about the second one? Now if you didn't realize that this will not give us a solution, and you went further and you said, I'm going to do the same thing, log on both sides. But then remember, ln of negative number does not exist. It is not defined, so this is wrong. So therefore we are not getting any solution from here. The only solution is x is equal to ln of 3. Going to the next example, now this one is, we see 10 to the x, like a to the x. So we have 10 to the x, but that's all I'm seeing, 10 to the, I'm not seeing 10 to the 2x. So cannot use the technique of the previous. But what I notice is that I can factor out. Actually, why don't we just bring this one or on the other side? I have x square 10 to the x minus x 10 to the x. So minus 2 10 to the x equals 0. Now I can factor out the 10 to the x, and I am left with x square minus x minus 2 is equal to 0, which implies 10 to the x is 0, or x square minus x minus 2 is 0. Now this is never going to happen, so the only solution that I will get is from this equation, which is factored as so it gives me these two values for x. Okay, looking at this next one. Again, in this one I see e to the x and I also see e to the negative x, but I am not seeing the x to the 2x, which means we cannot do it using the quadratic form. So how do I do this? Well, it has a negative x. So negative x, what happens with that? We can write it as 1 over e to the x. So equal to 1. So how do I go from there? Well, we don't like this thing sitting at the bottom, so we multiply the whole equation by e to the x. When you do that, you get e to the x times e to the x, which gives me e to the 2x. Minus, when you multiply the e to the x with the middle term, here, this term, I get negative 12, just negative 12, because these cancel each other, and equal to e to the x. Oh, well, now it is in the quadratic form. Okay, so you can write e to the x minus 4 plus 3 e to the x minus 4. So you can either use the U substitution, or you can directly do it like that. So we get e to the x equals negative 4, or e to the x equals positive 4, and e to the x equals negative 3. This is not possible, only this is correct. So e to the x is equal to 4 will mean now we convert to logarithmic form. So x will be equal to ln of 4. Okay, last part. Actually, that's it. So this is how you solve the exponential equation.